So I got a bunch of things I want to blast through. But before I blast through those, I'll just show you a little Go code. And so I'm going all the way to presentation 10. And I was kind of surprised when I started to lay out, let me show you how Go programming works, that I got that far before I actually really started doing a lot of code. Like, here's hello world with code. And then there's just some things in here about how does Go work. And like packages and docs and using libraries and some of the tools that Go has, and then reviewing it, and then talking about Bacchus and Nor, I don't even know how you say that, form, BNF, right? And how to read documentation and resources. Because one of the things I found frustrating when I was learning Go is I would look at the documentation, and I think I have an example of that right here. Let me see if it's reading the docs, if this is it. No, that's not it. Anyhow, I would sometimes go to the docs and I'd be like, man, not only did that not answer my question, nor did I understand, like what I went to find an answer for, but it just raised more questions. I'd be like, I'm totally confused by that answer. It's like I have a question, I go find the answer, and then the answer just confused me more. And so that's one of the things about, I thought, oh, maybe I have it. I do, I have it right here. So I showed you Go is invented by geniuses, right? But unless you speak genius, Go can be harderish to learn from the docs, right? So if you've never coded before, it's like, oh, what's all that mean, right? And so here's an example of that. So finally, each source file can define its own nalatic init function to set up whatever state is required. Actually, each file can have multiple init functions. And finally means finally. Init is called after all the variable declarations in the package have evaluated their initializers, and those are evaluated only after all the imported packages have been initialized. So when I was learning Go, I'm like, what? I was coming to learn about the init function. What's nalatic mean? Right? I don't know what nalatic means, and what's finally means finally. That seems like it's kind of like a joke. I don't get it. Right? Like, I just got more confused. And so that was like an example. And so for me, learning Go from the docs was kind of like most difficult, black diamond run, And the summer, fortunately, we put together, I had the good fortune of having a large chunk of money dropped into my lap for workforce development. So I put together the summer web boot camp and basically put together a web programming training 10 weeks long to learn from the people that I wanted to learn from. And so one of them, we hired this really great Go programmer, Caleb Doxey, and Caleb wrote this book, one of the resources that I'm going to recommend to y'all, and it's the Golang book, and it's a really well-written book. But so he came in and trained us for a month this summer, for 4 weeks, and that really clarified a lot of things, just working with somebody who uses it day to day and being able to ask them questions. So Go can be a little bit difficult when you first learn it. Caleb said, Go is a very well-documented programming language, but this documentation can be difficult to understand unless you're already familiar with programming languages. And that's from his book. That's in like chapter 1 of his book, and that's absolutely true. But when you're learning it with somebody who's kind of like showing you the way, right? Like learning it with Caleb this summer, it's like, man, that was so much more helpful. So I'm nowhere near Caleb's caliber, right? But I'm much farther along than I used to be. And so hopefully that's what this will be like in our course, learning Go in this course. So that was kind of surprising to me when I started to put all this together, was just like, here's a little bit of Go code right here. So I'll just show you that because everybody likes to look at Go. So here's, and I just like baby step you guys through in all of these presentations. Let me see. So here's hello world. Right? Let me come back up one. That's not hello world. I just want to get away from all these other things I put in here. Man, I just tore it up. That looks intimidating. We'll stick with this one. Right? But I just like, I'm going to rip this apart and show you all the pieces. Right? And do it in a hopefully really clearly well-defined. But, importing a package, or we're declaring a package, we're declaring a package, we're saying this is the main package, And then we're importing another package or library with code which we can access called format. And then we have a main function. And from the format package, there's a method called println, and we're using that method. And it takes as an argument, hello, a string. And so we're passing in a string. And so it prints out to the screen, it prints out hello world. And so that's like, a little bit of Go code right there. I'll show you a little bit more Go code, then we'll jump back in on the presentations. But let's see, what do we got here? So here's how you declare variables, and let me just view, present. So it's a little bit larger. So that's how you would declare variables, right? Same thing, package main, importing format, var a string is equal to, right? So that's kind of funny for people when they first start working with Go, if they've worked with other languages. A lot of times the type was in front of the variable name, so it might be var string a in other languages, but in Go they throw the variable type after the variable name. And I think that's, I don't know, my speculation as to why they do that is because you could do multiple assignments in one line, and var bc string, right? Those are both strings. And I don't know, maybe it's easier to see the name when you're reading the code, just to see the variable name before you see the type, right? So maybe that's why they did it. And so there's var d string, and you could also do the shorthand where it's just f := 43, and so the variable name is f, and the value that's being assigned is 43, and it looks at the value that's being assigned and then just figures out what's the best type. And so it would choose int for that, f = 43, it would go, I'll give that an int. So you could only do the : inside a function for variable assignment, but that's variable assignment. That's not too bad, right? That's pretty straightforward. And then here's how you do a constant. So constant p string is equal to death and taxes. Or constant q is equal to 42, and then it'll figure out the type. For constants, you don't need the : and so that's constant. So where can you use the : The only place you can use it, inside of what?
Inside a function.
You can only use : inside a function. So we were just looking at the : bit right here. And you can only use : inside a function. I'm in func main. I couldn't use : out here, right outside of a function, just right in the package.
So does that mean, like in JavaScript, that you couldn't call it outside of the function because it's not a global variable like the others?
Yeah, good question. So if I wanted a variable to be accessible through different functions in the same package, then my variable needs to be outside function. So I'd have to do like a var a, like lines 5, 6, and 7. And then any function within that package would be able to access that variable, right? So var a, b, c, and d are all accessible by any functions inside package main. Var a, b, c, and d are accessible by any functions inside package main. And if I'd made these capital A, capital B, capital C, capital D, var A, B, C, D, right, with capitals, would be accessible anywhere in my program. And I have 90% certainty on that answer.
At least you're honest.
Yeah, that's my probability. There's a little bit of doubt, but that's my understanding. And the way I like to try to do things is when I have that question, it's like, let me test that. And then I try to write some code to do what I'm wondering and see if it actually works. That's the best way to hack. We've got a self-professed hacker. He was extolling hacking outside my office door is awesome earlier. So I hack these computers all day long or something.
I've been waiting 4 years for that class, man. I got canceled. So, no security classes.
Has the FBI visited you yet?
I wish with a job or something, but no. No one comes at me with jobs. I gotta go ask them.
Well, I think once you, I don't know, you get good enough, you create your own kind of deal, right? So let's take a look at getting started with Golang. How do we actually set up the Go programming environment? And that's what this next presentation covers. We got like 37 slides. It goes pretty quick though. So my goal, just coming back to this thing, my goal is to make it easy to learn Go. I want to provide Tony Gaddis quality learning materials for Go. I want Go to become a popular widespread language. And I think Go merits becoming a widespread language. And I've really seen the momentum build with it. And one of the biggest things that stands... Tony Gaddis writes really great programming books that I've liked.
Does he have one on Go yet?
Tony Gaddis. No, he doesn't. But
That's a shame.
anyhow, here he is on Amazon, and I just loved his Java book so much. It's like, that's what I want to do. This book right there is great. One of the things that really sort of tells me Go's gaining momentum is also this right here, because in January they had Pluralsight had no trainings on Go, and then in February they came out, where is it, the dates? They came out with John's training, which is really nice, and I've since sort of become connected with him, and he's a nice guy, and then we have in April, creating web applications with Go came out, and then June and July, 3 more trainings came out. So some momentum picking up, I think. Yeah, I want to help out. That's a great resource, by the way, those Pluralsight trainings. So to install Go, right? Obviously, you're going to download it, and there's a link to go get it. So you can just click that link and download Go right here, and it brings you here. And then just scroll past all that stuff, and just here are the stable versions. And look for, like, I'm on Mac, so OS 10 right here, and I would choose this one, 64-bit, because that's mine. Install it right there. And if you don't know what bits are, I would go up to my Mac and choose About This Mac, and then here I would look, 16 gigabytes. It doesn't tell you easily in a Mac whether it's 64 or 32. If it's a newer computer, most likely it's 64. If it's older, it might be 32. But you could Google, how do I tell if my Mac is 32-bit or 64-bit? And that refers to the word size of your computer, which is basically how many zeros and ones your CPU could process at once. So 32-bit machines could process 32 zeros and ones at a time. That was their word size. And 64-bit machines process 64 zeros and ones at a time. So you get the 64-bit if you're running 64-bit. Likewise, if you're on Windows, here's Windows 64-bit, and here's a Windows 32-bit. And on Windows, it's easier. But you could just Google, how do I tell if my computer's 32 or 64-bit? And now you understand what that means. So you download it, right? And then you're almost ready to install it. You could run a checksum. So when I go to the downloads, it has this SHA-1 checksum right here, and just a bunch of numbers. And so what a SHA-1 checksum is it's going to take all of the code that you downloaded, and it's going to run it through a hash algorithm, SHA-1 algorithm, and it'll produce a number. And the way you do that at the terminal is you just type in at the terminal, open SSL SHA-1, and then the path to the file. And so when I type that in at my computer, you can see there I printed my working directory. I'm in users TM002, and then I went to CD downloads. I changed to the downloads folder, and then when I came into here, I said list everything that's in the downloads folder, and you can see here's the file I downloaded, and then I typed in OpenSSL SHA-1 Go, and then I just hit tab and it completes it. And so it did all that, and then I hit enter, and then it says the SHA-1 for that file is equal to, and then I compare that number, 8FD, I compare that with the number that was over here when I downloaded it, and it's the same number. So what that tells me is that there was this bunch of code up on their server, and they ran this process against it called SHA-1. And when they ran it, it created a hash, which means it just looked at all that code and came up with a random number. And it will always come up with the same random number. So when I download it and run it, it comes up with that. It's not a random number. It comes up with the same number. When I download it and run it, it comes up. If it comes up with the same number, I know my code is the code that they intended. If it came up with a different number, that means somebody might have tampered with it. It means the code's been changed. Right? Like they had it, here it was, and maybe somebody grabbed it, added some virus or something, and then passed it on to me. And if I had a different number, it'd be like, well, I'm not going to install that. That's not secure. That's not what they intended, right? So that's the purpose of your SHA-1 checksum. And so that's you do that at the terminal, and at when you're the command line is like the old way that people used to interface with computers before we had graphical user interfaces. And so there was two main types of operating systems that were out there with two different command systems. And one was a Unix-based operating system, and it's still true today, Unix-based operating system. And then the other is a Windows-based, DOS-based operating system. So DOS is going to use different commands at the command line than Unix-based computers. So Linux is Unix-based. Unix sounds very similar. It's actually Linus Torvalds Linux. And so Linux is a Unix-based. Mac is Unix-based, right? And Windows is DOS-based, or it's just got different commands at the terminal. And so I'm going to be showing you everything for Unix commands at the terminal. And if I do command spacebar, and so you saw me just open my terminal, I could have just come over to applications and found it, but there's the spotlight feature on a Mac, or just command spacebar brings it up, and you type in what you want and it'll launch it. And so that launches my terminal right there. So we'll be doing things at the terminal, and if you're on a Windows machine, we're going to be using GitHub too. And so you could get a terminal emulator on Windows, so you could use a lot of the same commands. And the one I'm recommending is just the one that comes with GitHub, the GitHub desktop operating environment. And so if you are on Windows, to do terminal stuff, you could go to GitHub install and download and install GitHub. And then when you run GitHub on the client, on Windows, you'll have a little option up here in the top right corner for settings. I think mine might be right here, preferences. And then when you go into, it looks nothing like this on Windows. Windows, GitHub, client, settings. Let's see what we get. Images.
Is this Git Bash you're talking about?
Yeah, and so right here, see, that's not it. I'm just looking. Windows, GitHub, terminal. Windows, GitHub, Bash.
Git for Windows.
And yeah, there's a setting. Oh, here it is. Sweet. Just when you're about to give up. Thank you. Git Bash. So you can come in here and you can turn on Git Bash right there in Windows, and then just hit update. And then anytime you do the GitHub terminal, GitHub Bash, that allows you to use Unix-based commands. Right, so if you're doing this on Windows at home, that's what you'd want to do. Questions? Okay, so if you're working on Windows, what do you need to do? Download GitHub client, right? And then just go into settings and say make it Git Bash instead of PowerShell, and then hit update, and then you'll go to your start button and go into the GitHub folder, and it'll be like Git Bash, yeah, and you click it, and then you'll have this on your Windows machine, and you could run things like ls, list everything in this directory, dir, doesn't do anything because that's DOS. Change directory, right? You could do ls, change directory, all that stuff. All right, so that's first we downloaded it, and then we checked the SHA-1, right? And then we're going to test the install, and so you could use Go version. And at the terminal, you just type Go version, and it should return, Go version, go, that. And it'll show you the version. So that means, hey, I've successfully installed it. So pretty easy to get started. Maybe I made it as clear as mud, though. What's the first thing you do? Download it. Second thing, check your SHA-1. That's just kind of interesting to know about. How many people show hands? That's new for you? Cool. And then the third thing is install it. Download, check SHA-1, install it. And then the fourth thing is, all right, let me go to the terminal and type in Go version. And you type in Go version, it should show you the version. Right? And notice that syntax is slightly different than Go version you often see at the terminal, which would be Go dash dash version, right? Or Go dash V, or Java dash dash version, or Python dash dash version, or Python dash V. You know, like here, Python, whoops, terminal. That's not it. I don't know what that is. Terminal, Python dash dash version. Right? 2 dashes, Python dash V. I don't know what the heck that just did. Python dash dash V. So, yeah, Control C won't get me out of it. I've entered Python now.
Quit open for it? Oh, you don't.
Close it, there we go.
The old fashioned.
All right, I'm out. So that's it. Download it, install it, download it, check your SHA-1 with that command at the terminal, right? Install it, open up your terminal, and type Go version and make sure you've got a version. So that Go version, there's a bunch of different Go commands, and so there's Golang.org where we'll have docs that you can look up, and so Golang.org is one place, and Godoc.org is another place. And I'll talk about the differences between the two. But here we have the different commands for Go. And so you can see some of those commands there. I think I actually have those all listed right here. So there they are. All right, so different Go commands. Like we just ran Go version. Cool, and it did something for us. Well, we're also going to use Go install and Go build, right? And Go format. So those are some of the different commands we're going to look at using and what they do to our code. So Go help is another one. It's not listed there. So that's like interesting.
It says go help and then the command.
Yeah. But it's almost like, that's where Go gets a little bit confusing for me, right? Like, it seems like help would be a command right there, because it's like, well, Go is my keyword and help is the command I want to run. But when I look at the different Go commands, help's not listed. We got build, clean, environment fix, format, generate, git, install, list, run, test, tool, version, vet. And then right beneath that it says use Go help command for more information about a command. So that's where that is, right? But it doesn't say that that's a command, because then if that's a command, how would you get information about the command? I don't know. So Go help command is right there for more information about a command. So that's where it takes like a little bit of figuring out. So if you run Go help, it brings this up, and it says, usage, Go command, and arguments. And the commands are, and use Go help command for more information about a command, or use Go help topic, and here are some different topics for more information about that topic. So we could type in Go help packages, or Go help Go path, and we can learn more about that. Or we could type in Go help version, and we can learn more about, hey, what do we get when we type in Go help version? Like what comes up? Go help version. Version prints the Go version as reported by runtime.version. What about Go help format? I saw that was one of the commands. So let me just start over there. And format runs the command on package's name by the import path. It prints the name of the files that are modified. For more information about that, Go format with specific options, run Go format itself. So, like I read that and I'm like, well, that doesn't really explain it the way I know it. Go format, what Go format does is it formats your code for you. And so that's really helpful in creating common code between different people. So Go is opinionated, and format puts your code into, and by opinionated I mean they say there are certain ways you should do things, and how you format your code is one of them, and there's reasons for why they say your code should be formatted a certain way. And so when you run Go format, it puts it into the proper format for Go code. And that way when you look at anybody else's code, it's not like, wow, they're doing their curly braces in a totally different place. I can't read that, right? It's like all Go code, no matter who wrote it, is going to look the same, assuming they wrote it well, but it'll be formatted the same. So that's Go Help. So one of the things I want you to take away is the different tools, the different tools and how we use them. So, there are those two things I just pointed out. So here's an exercise. I want you guys to try running Go Help at the terminal. And actually, you guys need a break? You want to do that right now?
Well, we still need to install Go.
No, you don't.
Oh, yeah, you already have
It's
it.
already installed
Oh,
here.
okay.
Yeah. So let's give it a try. And then we'll just pick up this presentation afterwards.
You already